Learning objectives. At the end of this topic, you will be able to explore the force of friction, investigate the factors affecting friction, analyze situations to decide whether friction is desirable or undesirable, suggest ways of reducing or increasing friction in our daily life, explain the methods to reduce friction. Introduction. Sheila and her mother went for a walk. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. You too slow down your bicycle whenever needed by applying brakes. Have you ever thought why a vehicle slows down when brakes are applied?
Yes, I've seen them.
Not only vehicles, any object moving over the surface of another object slows down when external force is applied on it. Finally, it stops. Have you not seen a moving ball on the ground stopping after some time? Why do we slip when we step on a banana peel? Why is it difficult to walk on a smooth and wet floor? Let me answer all these questions now. Let's perform an activity to understand about the force of friction. Let's conduct a small activity. Gently push a book on a table. We'll observe that it stops after moving for some distance. Let's repeat this activity pushing the book from the opposite direction. We have seen that if you apply the force along the left, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. In both cases, the force opposes the motion of the book. The force of friction always opposes the applied force. In the above activity, the force of friction acts between the surface of the book and the surface of the table. Factors affecting friction. Friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities in the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surfaces, there are a large number of irregularities. So, the force of friction is greater if a rough force is involved. So, the force of friction is greater if a rough surface is involved. We see that the friction is caused by the interlocking of irregularities in the two surfaces. It's obvious that the force of friction will increase if the two surfaces are pressed harder. You can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. On the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. When the box starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So, the sliding friction is slightly smaller than the static friction, and it's somewhat easier to move the box already in motion than to get it started. Friction, a necessary evil. We could not write with pen or pencil if there was no friction. When your teacher is writing with chalk on the blackboard, its rough surfaces rubs off some chalk particles which stick to the blackboard. If an object starts moving, it would never stop if there were no friction. Had there been no friction between the tires of the automobiles and the road, they could not have started, nor stopped, nor turned to change the direction of motion. You could not fix a nail on the wall or tie a knot. Without friction, no building could be constructed. On the other hand, friction is an evil too. It wears out the materials, whether they are screws, ball bearings, or soles of shoes. You must have seen worn-out steps of foot-over bridges at railway stations. Friction can also produce heat. Vigorously rub your palms together for a few minutes. When we strike a matchstick against the rough surface, it catches fire. We might have observed that the jar of a mixer becomes hot when it is run for a few minutes. Increasing and reducing friction. We know that the sole of shoes are grooved to provide the shoes better grip on the floor so that we can move safely. Similarly, the treaded tires of cars, trucks, and bulldozers provide better grip with the ground. We deliberately increase friction by using brake pads in the brake system of bicycles and automobiles. When we are riding a bicycle, the brake pads do not touch the wheels, But when we press the brake lever, these pads arrest the motion of the rim due to friction. The wheel stops moving. In some situations, however, friction is undesirable and we would want to minimize it. You might have noticed when a few drops of oil is poured on the hinges of a door, the door moves smoothly. A bicycle and a motor mechanic use grease between the moving parts of these machines. In all the above cases, we want to reduce the friction in order to increase efficiency. When oil, grease or graphite is applied between the moving parts of a machine, a thin layer is formed there and moving surfaces do not directly rub against each other. Interlocking of irregularities is avoided to a great extent. Movement becomes smooth. The substances which reduce friction are called lubricants. In some machines, it may not be advisable to use oil as a lubricant. An air cushion between the moving parts is used to reduce friction. Wheels reduce friction. We have seen attaches and other pieces of luggage fitted with rollers. Even a child can pull pieces of luggage. When one body rolls over the surface of another body, the resistance to its motion is called the rolling friction. Rolling reduces friction. It's always easier to roll than to slide a body over another. That is the reason it is convenient to pull the luggage fitted with rollers. Since the rolling friction is smaller than the sliding friction, sliding is replaced in most machines by rolling by the use of ball bearings. Common examples are the use of ball bearings between hubs and the axles of sealing. Fluid friction. We know that air is very light and thin, yet it exerts frictional force on objects moving through it. Similarly, water and other liquids exert force of friction when objects move through them. In science, the common name of gases and liquids is fluids. So we can say that fluids exert force of friction on objects in motion through them. The frictional force exerted by fluids is also called drag. The frictional force on an object in a fluid depends on its speed with respect to the fluid. The frictional force also depends on the shape of the object and nature of the fluid. It's obvious that when objects move through fluids, they have to overcome friction acting on them. In this process, they lose energy. Efforts are therefore made to minimize friction, so objects are given special shapes. Birds and fishes have to move about in fluids all the time. Their bodies must have evolved to shapes which would make them not to lose much energy in overcoming friction. We find similarity between the shape of an aeroplane and that of a bird. In fact, all vehicles are designed to have shapes which reduce fluid friction. Summary. Let's summarize the topic. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. Friction is caused by the interlocking of irregularities in the two surfaces. A moving object can never be stopped if there were no friction. Rolling friction is the resistance to its motion caused when one body rolls over the surface of another body.